Hello, receiving students, ATs, and receiving teachers. Thank you. Take your seat. Okay, like I've said in a previous lesson, before we go on to our today's lesson, we will go and recap the answers to the activities that we did in our previous lesson. Let us look at the question. The activity 1, calculate the probabilities of getting a head-head, tail-tail, head-tail after tossing 2 coins 50 times for your group. Receiving students, the result will come from your own result that you have collected. Group 1. What is your result for head-head? The probability for head-head, 17 over 50. What is your percentage? Percentage 34. Okay. Tail, 14 over 50. And your percentage? 28 over, 28%. And head, tail? 19 over 50. Percentage? 38, huh? I expect you other groups to do the same here. This is group 1's result from tossing of 50 coins. 50 coins that was tossed. Out of that 50 coins, 17 out of 50 was head-head. 14 out of 50 was tail-tail. And 19 out of 50 was head-tail. So the probability for head-head is 17 over 50, tail-tail 14 over 50, and head-tail 19 over 50. You can also see the percentage of the probabilities. They have also expressed the probabilities as percentage, like head-head 34%, tail-tail 28%, and head-tail 38%. Other groups, you will not have the same result. Your results will be different from group 1's. Okay, let us go to activity 2. Our activity 2 is to calculate the probabilities of getting head-head, tail-tail, head-tail for all the groups after tossing 2 coins 500 times. Remember, we did not toss the coins for 500 times, but assuming that we have tossed the coins for 500 times. And that is from all your results. All your results that we have put together makes up the tossing of coins for 500 times. Receiving students, you will not have the same result as the model class. Your results will be different depending on the number of groups that you have. So, can we have a Group 3 to give us the result? Okay, I have the table here. Group 3, after calculating the results for all the results, what did you get for head-head? Okay, group 3 is thinking, still deciding for the answer. Let's have those others who have got the answer for head-head. What result did you get? Remember, this column here is the theoretical result. But what is the experiment result? Experiment result is taken from adding all these results of each of the groups, from group 1 to group 10. So what is the result of head, head, tail, tail, and head, tail?
134.
Okay. Group 10, what did you get? Same, 134. Now, if you add all the results, you're going to get 134, and 134 is the correct answer. Adding the results from group 1 to group 10. What do you think will be the results for tail, tail? 134. And head, tail? 232. Do all these results add up to 500? Yes. So, now you can see the experiment probability for head, head is 134, for tail, tail is 134, and head, tail is 232. This is our theoretical result. What we expect, what is being agreed upon. We expect to get this, but when we actually did the activity, we did not meet this result. Receiving students, you will not have the same answer as been given here. Like I've said, it depends on your number of groups that you have. Let's go to activity 3. Comparing the probabilities of head, head, tail, tail in activity 1 with the probabilities of activity 2, is there any difference? Now, I want you to look at your results and compare with the results that we got in activity 2. Can you see a difference there? Can you see some difference? If you think that there is a difference, then what is the difference with the results that you got in activity 1 and activity 2? So can I ask group 4? Group 4, can you give us what difference that you find out from your result in activity 1 and result for activity 2? Katrina, ready? Let's listen to Katrina.
The difference is in activity 1, we found a probability using the tally that we did, tossing the coins 50 times. Then we got our answer, and then we found a probability in percentage. And from activity 2, we found a probability using the overall result, which was over 500, meaning that head plus the tail plus the head tail, which gave us the 500. It's the full result.
So what is the difference?
Percentage.
Percentage? What do you others think? Remember, when you toss the coins for 50 times, you did not get closer to the theoretical probability. Yes?
Our answer was, the difference is that in exercise 1, we calculated the probabilities of getting a head, head, tail, tail, and head, tail after tossing the coins 50 times. While in exercise 2, we calculated the probabilities of getting a head, head, tail, tail, and head, tail after tossing the coins 500 times.
So, okay. I will tell you the difference. Now, let us look at group 1's result here. If you look at group 1's result, the probability is 17 over 50. Remember, two coins been tossed for 50 times. This one, 2 coins been tossed for 500 times. The probability of head for 500 times is 134 over 500. And tail will be 500 over 134 over 500. Head tail will be 232 over 500. The percentage is 27%, 27%, and 46. To the nearest decimal. Now, comparing this with our theoretical probability. With the theoretical probability, which of these results this is group 1's result, and this is the whole group's result. Theoretical result, if we compare, there is a difference. When you toss the coins for 50 times, we did not, the result was not closest to the theoretical result. But if this coin was tossed 500 times, the experiment result is closest to the theoretical result. And that is the difference. So, what I am trying to explain here is to meet or to get closest to the theoretical probability, you must toss many, many times to get to the theoretical probabilities. If you toss the coins just for 20 times or 50 times, you will likely get closer to the theoretical probability. But if you toss it for many, many times, you will get closer to the theoretical probability. And here we have tossed this for 500, and it is not really close to the theoretical probability, but close, almost close. If we toss it like 1,000 times, 5,000 times, or 2,000 times, you will see that this result is going to change rapidly. As many, many times we toss the coin, we will get closer to this theoretical result. And that's what probability is. You don't have to toss it for only less than a number. You have to toss it for many, many times until to get to the theoretical result. So that is the difference. Tossing it many, many times will lead you to get to the theoretical probability. Receiving students and ATs. Those are the results for our previous activity. And the important thing, to get your answer closest to the theoretical probability, you must always toss the coins many, many times. That is the secret. The more times you toss the coins, you will come closer to the theoretical probability. We will go to our today's lesson. Our today's lesson is on strand, change, and data, substrand, statistics, learning outcome, interpret information presented statistically, and lesson topic for today is on language of probability. Now, I would like us to look at the screen. On the screen, we have an image of a coin or picture of a coin. Let us look at the coin. Now, class, if that coin is tossed, what is the probability or chances of this coin landing on head? What is the chances of the coin landing on head? Or what is the probability of the coin landing on head? If the coin is tossed. What is the chances of the coin landing on head? Samuel?
50%.
Samuel says 50%. Can someone express that in fraction? Fraction? Half. How do we express that? These are in numbers. How do we express that in words? Is there a common word that can express that we express 50% or half
50% of
in words?
half a coin.
Okay. 50-50 chances. Fifty-50 chances or even chance. So, when the coin is tossed, the probability or the chances of getting head is 50%, half, or in words, 50-50 chance, or even chance. Not 50-50, 50-50, it's supposed to be 50-50. Now we said that the chances are 50%, 50-50, even chances, or half. Why? Why is that? Receiving students, why is the chances 50-50% or 50%, half, 50-50, or even chances? There is a reason why it must be 50%. Your answer is correct, but why? Okay, I'll give you time to discuss. 1 minute. 1 minute. Receiving students, please discuss your answers among yourself. Why we say that the chances of the coin landing on head is 50% or half, 50-50, or even chances? Okay, 1 minute up. Mark, let's have Mark. Mark, can you give your answer? Brainstorm your answer why you think it is 50-50 chances.
Because the coin has two sides and it can either land on one of the sides or it can.
Did you hear what Mark said? Very good. That answer is correct. If you look at the coin, there are only two possible results, which is head or tail. So it can be either head or it can be either tail. Therefore, the chances of coin landing on head is half, 50%, or even chances. It's because of there are only two possible answers. Let us look at another example. The other example is given there on the screen, which is a die. Sorry, if the dice is thrown, what is the chances of the dice landing on 3. Remember, there are 6 sides. So what is the probability of it landing on 3? Yes, Catherine?
3/6.
Catherine says 3/6. What about you others? Okay, Samuel?
1/6.
1/6. Which of these two answers are correct? 1/6. Okay? 1/6 is correct. So, the chances of the coin landing on 3 is 1/6. Remember, there are 1, 2, 3, 4, 5, and 6. So, how many possible results? How many possible results? There are 6 possible results. And if you throw the coins for once only, you either have the chances of having 1, 2, 3, 4, 5, or 6. So it is either one of these. So the chances of getting 3 is 1/6. Now this is in number. How do we express that in words? Okay, we express that in word as unlikely. The probability is unlikely. Why? Because there are 6 possible answers, and the chances of getting 3 is unlikely. In other words, the probability of getting 3 is very, very low. It is not high, very low. Because we have more than one result. There are 6 results. So the probability or the chances is very low. When you throw the dice in one throw. So the word used is unlikely. Before we go into our activity, I'd like us to look at few words and numbers that can describe probabilities. Let us look at the words that can describe probabilities on the screen. So when you describe probabilities, those are the possible words that you can use. Any event that is impossible, that cannot happen, the probability of that event cannot happen, it is described as impossible. And impossible probabilities are always 0. Any event between 0 and 0.5, which is also known as half or 50%, it is always even chances. And the probability between 0 and 0.5 is very unlikely or likely. The probabilities of event between 0.5 and 1 is very likely or likely. You can see the bar there. The bar has been labeled with colors on how you can express the probability of an event. Now, the event closest to 1 is always regarded as very likely. And 1, any probability that you definitely know that it will take place, happen, it is always certain. And in numbers, it is described as 1. So, probability is measured between 0 and 1 and not beyond 1. When we measure probabilities, we measure between 0 and 1. So probability lies between 0 and 1 only. And it is not beyond 1. Is that clear? Okay. I'll give you time to copy this. You have it in your book. Okay. Receiving students and 80s. I think you have the similar diagram in your exercise workbook, so we will proceed on to the activity. Activity for today. Describe each of the events as impossible, likely, unlikely, even chances, likely, very likely, or certain. So the activities A and B. Okay, A and B is given there. What is the chances of cassowary flying? So, okay, write the answer to that question. B, what is the probabilities of a pregnant mother giving birth to a baby boy? Very simple exercise, so it shouldn't take you that long. Shouldn't take you that long. Last 1 minute. No need for you to copy down the question. You only answer the question. Okay, we will move on to the next activity. C, what is the chances of having rainy day tomorrow? C, and D, what is the probabilities of you coming late tomorrow? Okay, it shouldn't take you that long. Very simple questions. I'd like you to keep the answers for these questions, and in our next lesson, we will quickly go through the answers together. Now, receiving students, if you have received your worksheet book, you have extra exercise given on the worksheet book. At your own time, you complete the worksheet. Likewise, model class, you have also extra exercise based on this activity which is given there. So at your own time, please complete those exercises. Finish answering the questions. Okay, receiving students and 80s, our next lesson we will correct the answers. But before we sum up, I'd like you to copy down these additional notes. Okay? Quickly copy down the additional notes. Please write fast, write quickly. Receiving students, you must quickly write the additional notes faster because we are running out of time. So move your fingers fast. Okay, receiving students, I'll move on to the last. Okay. receiving students and ATs, our key phrase for today is language of probabilities. And our next lesson will be equally likely outcomes. And materials will be as given. Thank you, ATs and receiving students, for your participation.